Hello everyone and welcome to our webinar about openLCA and AGRIBALYSE 3.1, its integration. In this presentation we will look into, first of all, openLCA 2.0 and resources, because the demo I will be showing at the end will be in openLCA 2.0 and therefore I have to briefly introduce it. Then of course we will be looking at AGRIBALYSE 3.1 and openLCA. So how to obtain it, which methods to use, the compatibility with other databases in openLCA, the migration of models from the previous version that you've been using to 3.1 if you have already been using AGRIBALYSE, and also the structural organization. We will be looking at it in openLCA, where then we will also be doing a demo. So let's take a look a bit at openLCA 2.0. First of all, let me say that openLCA 1.11 is still in use at the time of releasing this video, and the AGRIBALYSE version 3.1 is released in openLCA 1.11, so the database that you will download is already in 1.11. But you can also use it in 2.0. It's very simple. You open the openLCA 2.0 and then you click on AGRIBALYSE and then click on update. So a window will pop up, and from when you're opening old databases in openLCA 2.0, a window pops up and then you just click, I want to update this database, and then it works fine. So where to download openLCA 2.0? This is in the link here. I will also put it in the description of this video, so you can find it there. And what's some features that I'd like to highlight about openLCA 2.0 is that it has faster calculations. It uses libraries, which are pre-calculated databases, and therefore really this makes the calculation be instant. However, if you haven't done a library, still already it has faster calculations. You can store results this time and work with scripts that you can also store. For example, Python script or SQL script. This is now it's able to be stored in openLCA. You can work directly with EPDs in openLCA, so link your LCA to an EPD. It has a known folder called EPDs now, and other things here are tags, which are extra information that you can add to at a process or flow level, and of course extra regionalization, for example, of flows. Now they can also be regionalized, and this helps not having many flows for the same flow depending on the location. So if you are new to openLCA, or if you're not, it's always good to understand where you can find help and resources for openLCA. So we have the manual, we have a YouTube channel, which you're probably in right now to watch this video. Then we have case studies available. These are always having a report and a database together. Sometimes there's also a video that we publish with the database. And this is the central place where you can look at them all. And then we have some trainings and specific support for you that you can also book through our marketplace openLCA Nexus. And all of the links will also be available in the description of this video. If you want to be up to date with openLCA, this is really the central place to go. It's the openLCA blog. It's inside our openLCA website, and then you can see there, you click on the blog. Here we really have all of the updates of the databases, latest releases of the software, etc. And then these blog posts are further published in social media, but not all of them. So really, if you want to be up to date, you should check our blog. Then let's get into AGRIBALYSE 3.1 for openLCA. How to obtain it? You should go to our marketplace for LCA databases, openLCA Nexus, which is available at the link there. And this time there's new license conditions. To be able to download AGRIBALYSE, now you need a Nexus license for EcoInvent. And there's no need to contact us. This is already done automatically in Nexus. AGRIBALYSE uses background data of EcoInvent, and therefore this new release comes with these license conditions. Then AGRIBALYSE recommends to use the environmental footprint method for their database. The method package of openLCA already has EF 3.0 adapted method, which you can download, which is already present in the database under openLCA LCIA methods 215. And also AGRIBALYSE came with an EF 3.1 interim for AGRIBALYSE method. This was provided by AGRIBALYSE and now works with openLCA and AGRIBALYSE 3.1. All of these methods are already included in the database package that you download when you download AGRIBALYSE. And if we release a new openLCA method package, you can also import this new method package to AGRIBALYSE. But the EF 3.0 and the EF 3.1 methods that are already there work with AGRIBALYSE, and it's fine. So compatibility with all databases in AGRIBALYSE, in openLCA. So AGRIBALYSE uses the openLCA reference flow system that works with the openLCA LCIA method package, and so this allows it to be used along with other databases that also are in the openLCA reference flow system, which means that they also work with our method package. So, for example, you can use AGRIBALYSE with EcoInvent. And when you have merged or you have imported AGRIBALYSE into another database, beware that AGRIBALYSE has been cross-checked for the environmental footprint methods, and therefore these should be applied when you're also using other databases for results. So let's say you already are working with openLCA and AGRIBALYSE, how to then migrate your model to the new model. So first you have to export your model and then import it in the new database version. So you have your previous model here. We have, for example, a pizza, a model for an LCA of a pizza. So you make a product system and you right click and click export. This opens a new window and you can export in JSON LD file, which will look like a zip file. So you click on what you want to export and then it will make a zip file in your chosen directory where it's going to be saved. So now that you have a zip file, which is a JSON LD file, then you can go into your new database, right click, click import, and then you want to import a JSON LD file, and you click next, and you have to choose the directory. A lot of people get hung up here. When you click browse in this window, you don't look for the file, but you look for the directory, meaning the folder where this file is in. And therefore you click on the directory, so the folder where the file is in, and then this window will show you your options of this directory for importing a JSON LD file. One of them will be your zip file, and so you click on it and you click finish. So a bit what it means to migrate the model. So the exported version 3.0 model will sit on top of the new database, meaning that the supply chain will not be connected. It will have its own supply chain. It works fine. You can calculate results. It will give you exactly the same results, only that the new processes haven't been updated. This is because the new AGRIBALYSE, the processes that might be the same as the previous AGRIBALYSE, they have different UUID numbers, and therefore for the system, the system thinks that it's a different process. A UUID is a unique identifier of that process. So you have imported your model into the new database. It works already fine. You're at the same point as you left it, and now you can be using the new processes to model to continue your modeling. So let's say that this is the last point in the slide. Let's say that you want to really have the new supply chain of the new database. So what you do here is that you can manually connect the imported model to the database. If it's very huge and you have the capacity and the skills to use Python, you could also do it like that. Or if the model is not too big, you can try to model it again in the version 3.1. It's intrinsically looking the same as the previous, so you won't have many problems on that. How it looks then, before it used to have this folder structure, so divided in openLCA, divided into the different sectors and activities, and now the database came in using these main folders, and if you expand these folders, then you get the same information as before. Beware that to the right in the new 3.1 version, we have also the case study that I will be presenting now. So the database comes strictly from energy to waste treatment, and the AGRIBALYSE 3.1 case study is an extra that I've made. So you won't be getting that when you download AGRIBALYSE from Nexus. So without further ado, let's get into the case study. We will be looking at an LCA of a pizza. The functional unit is 1 kilogram of pizza, and we will be looking at two pizzas, the 4 cheese and the Reine pizza. These are the two most common pizzas in France. And it's a simple case study. Here are the system boundaries. We have cooking, packaging, distributing, retail, and use as the foreground model. And then, of course, this is connected to the background database to connect it down to raw material extraction and to complete the life cycle. So this is how the system boundary will look in openLCA. I have numbered the processes I've been modeling with numbers to go from one to the next. We cook it, then we package it, distribute it, retail, and use. These are all together into one process. Usually you have two options. Either you do a cascade modeling where cooking then feeds into packaging, then feeds into distribution, and so on. And in this way, how I've done it now is doing individually all of the life cycle stages and then putting them all together into a single final process. This helps me visualize then results better in the contribution tree when I've already calculated results. So then let's take a look at the live demo. I will go to my openLCA, and here I have my database, AGRIBALYSE. So I have modeled the 4 cheeses and then the Reine. I will first go to the 4 cheeses. So I have inspired myself to do this pizza with the already existing pizza that AGRIBALYSE offers. So in order to have a pizza, first we have to cook. We have this cooking phase where I will need some ingredients like cheese, mozzarella, and roquefort. There's a lot of cheeses because this is a 4 cheese pizza, but also tomato and flour. Okay, then I need some energy and resources to cook, to be able to cook. That's accounted for by this flow, and then we need some water also. All right, let's look at the packaging. So in the packaging here we have a corrugated board box, so this will be my packaging, and it already has some transport that accounts for internal transport of this process. And then we have distribution, retail, and use. So let's go quickly through them. So in the distribution, we have that, maybe it says it in the general information. Well, we have some transport, but also this transport is chilled, and therefore we will be using some electricity, some energy to transport our pizza. So there's a description field in openLCA that you can put more information. So why is this electricity here? So it's cooling at distribution derives from distribution energy default for chilled products. Then we also have some emissions that are attributed specifically for distributing our pizza, okay? And then we have retail and use. I am going to show you how to create one process. So I go to my folder, I right click, create new process, and I'm gonna create an intermediate process here. So I'm gonna call it cooking pre or post processing for cheeses. I create a new flow. I'm gonna call it the same, and I'm gonna make the reference flow property be 1 kilogram, and therefore I choose mass. So here, if I want to, for example, have some energy from some, let's say I need to have energy to further cook my process, and therefore I'm gonna choose it I'm gonna choose electricity at low voltage. It's gonna be, let's say, 5 kilowatt hours. This is not precise. And in this case, for example, we have Caribbean. Let's say I want to do it in France. So how do I get electricity from France? I go inside the database, so I go to energy, others. So these really electricity mixes, etc., are provided by Ecoinvent originally. So I go inside my here energy others copied from Ecoinvent, and I'm trying to find low voltage for France here. So I can drag and drop. I'm gonna eliminate the previous one, and this one now I have electricity from France. So I'm going to again put the same one, okay? Then I always click save all, okay, so that my model's keeping updated. Good, so now we have it actually in my case study. You can see it here, 1.1 cooking post-processing, okay, just so that we could see it. Let's go to our final process, the one that has all of my flows, my processes together, okay. Let's make a product system to then make a calculation. So I want to now run the results, so I make a product system, which is the next folder here. Okay, and then here we can actually in the model graph see our supply chain. In openLCA 2.0, one can also, you know, model at this point. So we've enabled modeling at a model graph where you can, for example, also add nodes, etc. And enable you know, for example, to add a process or then to modify processes inside. So this we will explain maybe on a later videos or the manual, but today it wasn't about that. So just to visualize what type of process we're having before running the calculation. So there's this number of processes, so over 1,000 processes that are linked with each other to make the supply chain or the life cycle assessment of this. So you can understand the how big it is. So here I've clicked on calculated, and then I'm gonna choose my impact assessment methods to be environmental footprint 3.1. And with this database, we're gonna keep the calculation type to lazy on demand. All right. Then if we have included any costs for life cycle costing or data quality, we can check these to also calculate it. But in my specific model, we don't have it, and therefore I'm not clicking them. So now we have the results. These are the different results tabs to visualize the same information, which is the results, okay? So in the second tab, inventory, we have a summary of literally all of the inputs and outputs of this model, and also visualized in processes, but mainly in its smallest building blocks, which are elementary flows, okay? Then we can have, in the general information, we can understand the top 5 contributions to the impact category that we want. So, of course, there's a big block in others, but let's see the individual processes that contribute. So the red one is sheep milk, the blue one is goat milk, and then furthermore we have another milk, the green one, cow milk, land use, etc. Meaning that it seems that already that a lot of the impacts come from milk, which is the cheese. In the impact analysis, the third tab, we really have a summary of all of the all of the results. So here we can also understand where the impacts are coming from, and if I want to see it in processes, I can click on processes and I can actually see where they're coming from. Yeah. So another one that I wanted to show you is the contribution tree. So here in climate change, we can see what's contributing the most. So 92% of the impact are actually coming from cooking, and specifically from cheese, as you see here. So this really tells us a bit more about it. And this is a bit the results. So let's move on to the next folder here, projects compare product systems. So as you see, I have here um, the life cycle, well, the product systems for the life cycle of a pizza. Actually, I already had created one and I've renamed it the same. So how do I know which one's mine? I can click here to link with navigation panel, and then I can see it. So I'm gonna just rename it so that I don't get confused. Good. So let's then compare two product systems. I will create a new project, comparison of pizzas, which will be for cheese versus rain. So this is a project. Here I can then decide which impact assessment method I'm going to use in order to calculate this. And also I can then drag and drop what I want to calculate. So this one will be the 4 cheeses, and this one will be the rain. Okay, so I click save all. I want to create a report. Here I have the default sections of my report. It pops up when I have clicked on create reports, and I can be adding more sections here as I wish. Okay, I'll just leave it as a default and click on calculate. And so now it's calculating both product systems and making a comparison. So we will have graphs and also literal figures of both product systems as a result. Okay, so this is first of all the results. These things you can always be um, copying and pasting into Excel. Okay, so openLCA allows you to copy and paste anything that has cell looking information. You can right click copy always and then paste it into Excel. And if we look at our report, so I have put it in defaults, so I could of course change the introduction, etc. Um, and here down here I start getting my graph. So in comparison, the four cheeses and the rain is more impactful in climate change than the four cheeses, but we can also see, okay, what about water use? Actually, the rain is more impactful by quite a bit. What about resource use for fossils or human toxicity? And actually at the end, you have a comparison of both. So actually the 4Gs in acidification would be worse than the rain. And here you have an overall view. Then let me show you some, I think, very cool extra thing that we've added in this video, which is parameters, okay? So I have here, this model is also parameterized. So I want to show you how it works with parameters. So the very quickly, the rain has been parameterized, meaning that inside my inputs and outputs, not only I have numbers, but also parameters. You can be adding parameters in openLCA at 3 levels. So you have the global parameters here. You can right click add new parameter, and then the whole database will see this parameter. Or you can go inside process and go to parameters tab here down here. It's the 1, 2, 3, 4, 5th tab, and then you can either see already the parameters you have, or you can input by double clicking a new parameter. Parameters should have no spaces in between. So also parameters, new parameter 2. Parameters already have, well, they don't have, they're only numbers. So if you want to describe what it actually means, you can do it in the description. So this is letters. And then dependent parameters, you can add it here. So basically, if you want to make some sort of formula or calculation, you should just put it here, and then you can use it. Of course, save all the time. And then in inputs and outputs, we have then these parameters. If you click here to the top right, then you can see actually what it looks in numbers. And if you click on the FX, you can see how it looks in the formula. So we've included here 2 types of parameters. First of all, we've included an extra cheese. Okay, so we want to see what happens if it's a bit of a sensibility analysis what I'm doing here with parameters. What happens if I have an extra more cheese? And then also what happens if I'm using plant-based ham instead of cooked ham? So these 2 parameters, 2 sets of parameters are intrinsically different. So the extra cheese is a parameter that holds a number. Okay, so if I want to put extra cheese, then I put this parameter to be instead of 0, 0.5. Okay, and the cooked ham versus plant ham, as you can see, we have here both. These parameters are switch parameters, so they will be either 1 or 0. 1, when regular ham is 1 and plant-based ham is 0, then my pizza is normal pizza. And when plant-based ham is 1 and regular ham is 0, then the model will only be seeing my plant-based ham because the amount here will be 0, and therefore my pizza will be vegetarian. So I have or we have been looking at this at a project level, okay? So scenarios for rain, we've made another project for the scenarios. We have included the same product system, which is the life cycle pizza for rain, and we have included these three options: one for extra cheese, one for regular cheese, and one for vegetarian. So what you have to do is be using the next available section in the project, which is parameters. Here you add a parameter by clicking on the green button. Um, then you look for it, extra cheese, and then you click OK. We have already included here all of my parameters that we're using. And so for each of the comparison product systems we have, you can set each parameter as you want. So in the extra cheese one, we want extra cheese, and actually we want yeah, exactly, we want extra cheese, and we want regular ham. So it's just only the normal pizza as it usually is, but with a bit more cheese. The rain regular, then it doesn't have extra cheese but has regular ham, and the vegetarian doesn't have regular ham anymore but has a plant-based ham, and this is the switch parameters that we're using here. So without further ado, let's then click on calculate. So I want to create report, and then I click on calculate, and so it's calculating the three options. And comparing them between them. So we will see which one out of our scenarios maybe is more impactful. We can already see from here that actually extra cheese really makes a difference, but using vegetarian ham is also making a big difference in climate change. Of course, we can look into other type of use. For example, we can see here that actually using using a normal pizza and having extra cheese or not doesn't really make that much of a difference in water use, but having a vegetarian pizza does make more of a difference comparably. Okay, so we have here the reports where we can visualize this. Let's go to the end. We can see here that, of course, the vegetarian one really makes a difference in terms of environmental impacts. And the extra cheese one is, of course, the worst. Okay, so with that, thank you very much for looking at this video, for watching us. My name is Julia. I work at Green Delta as a sustainability consultant and researcher. If you have any questions about this video, you can email us at Green Delta. We want to publish this case study so that it's available for everyone also to download. And yeah, thank you very much.